Hey, what's going on, guys? Good, Mikey Gaines here. I was already about to drop this series on trying to bring together Monte Carlo research algorithm with Stockfish NNU evaluation because I kind of reached the point of satisfaction within this experiment. But here I got a comment from Matt. I can't read this last name, unfortunately. So let's say the comment from Matt, who said like he can't wait for part 3. So and actually I did reply to him as well, like I didn't intend that. And well, actually I did find some sort of an improvement to an existing version, even though it's not, like just a few words regarding the background first, and then we'll proceed with writing some code and actually try to make it a little bit better. So there are kind of two major approaches regarding Monte Carlo research. So the first one is the approach that is initially used by kind of Leela chess0 type engines, or AlphaZero type engines to be more precise. Is they use a completely different type of a neural network compared to Stockfish and it's not even the matter of having really more hidden layers and literally using deep learning there instead of quite pretty simple structure of Stockfish's NNE. But the major difference is that the Leela type neural networks actually have so-called policy head. And policy head means that for every given position, it returns the list of moves. The neural network returns the list of moves, apart from the evaluation. The list of moves where every single move has a probability value of how likely is the network about to win the current given position by playing this or that move. So, like say you have the initial position like e2 and e2 e4 d2 d4 would have the most winning probability, like say, I don't know, like let's say 75%, let's say 75% for d4, let's say 73% for e4, and let's say 5% for a3. Okay, so just to give you an idea, so it's kind of clear like which move is about to pick up there. And well, obviously, it's not only the matter of neural network to choose which kind of move to pick up. And here's where the Monte Carlo research comes onto the stage. So the idea is that Monte Carlo research is doing its job, but when it comes to selecting the best move, it also from the given root node that has been taken as an input, it's not only relies on its own algorithm, which is called UCB1, or its extended version called UCD, which is upper confidence bound for trees. So this sort of formula is being modified so the policy head is taken into account, and the engine is more likely to make a move that where the neural network influences this winning probability the most. And that's the exact way how the simplified Leela type engine AOLite, which we were playing against in the previous part, is working. So its neural network has actually that sort of a policy head along with a value as well. So as far as Stockfish NNE is not really designed for this sort of a predictions, it's just a matter of that it's designed to give a static evaluation for a position derived from the alpha beta search, basically. So it's not really about to say anything regarding the probabilities of how in particular what kind of move would be better, basically. So it's not intended. And initially all this idea to try this was intended to answer the simple question like how the Monte Carlo research would be performing without this policy head that is returned by Leela type networks. And the answer is very simple. It most likely would be blundering pieces from time to time. And here we're coming to the very last improvement that I came up with regarding this project in particular. And again, I wouldn't even be doing that personally, because whatever improvement we do without this policy head, it's just doomed to blunder pieces sooner or later. But anyway, as far as I get this commentary, I really want to make a little more effort to actually achieve slightly better results. So this was the initial approach. So with NNU, we can actually have we don't have the policy head. That's the reason why we can improve in this sort of a manner. And another major approach, which is also quite pretty complicated, well, at least for a dumb noob like me, it's too complicated. So another approach would be to use so-called alpha-beta rollouts. And what we do instead of making a rollout, which is literally a random, if we're talking about the light rollout policy in Monte Carlo research, is the matter of the random game simulation, like here in the initial implementation. But what we do here, we're just returning the static evaluation without actually searching the position. So and let's say if we just face the position where, let's say, queen takes pawn, and we think like we're pawn up, we're better here, but the next move this queen would be captured by opponent's piece, whatever it is, and eventually we lose a queen. So this is really bad scenario, and this is something that is happening within the game quite pretty often. So it's the only thing that I was trying to reduce in this final kind of version that we're supposed to be writing in this very last live stream regarding this topic. So I've chosen somewhat in between. Well, it's not in between really, but I've chosen something. Something easy probably. So I decided to implement a very simple quiescence search, and every time when we face a material imbalance within the current given state, within a node, when we're trying to return the evaluation for that node. So if there is no material imbalance, in that case, we would be returning this static evaluation straight ahead. But if we have some, let's say we have a move where Monte Carlo research sacrifices a piece, like say, I don't know, like a bishop or even a queen, and obviously that's kind of bad thing, so we try to avoid that. So how do we detect that sort of stuff? We just ask whether the material imbalance has occurred on a chessboard, and if it is, in that case we would run our quiescence search to return the score from the quiescence search, which by saying quiescence, for those of you who are not aware, what is that? Quiescence means we're generating only captures until the quiet position where no captures are available is reached on the chessboard, and then we return that evaluation. So the idea is, let's say we have a complicated situation on the chessboard where it's the matter of many exchanges followed by each other, like some sort of a forcing line. So in this case, the evaluation that we care about is how many material would be eventually will eventually have after the entire sort of exchange or forcing line has been completed. So let's say if at the very end we win something, that's good, so we should have considered that. But if at the very end we'll end up losing material, well, obviously we shouldn't go for that forced variation. So that's kind of the simple idea I have implemented. It's, even though it's using the alphabet search in terms of a quiescence search here, still it can be treated as the alphabet or as the true alphabet rollout, because the true alphabet rollout is much more complicated, and I don't really want even to look there, because like it's a completely new territory for me, and I was wondering like how the pure Monte Carlo research algorithm performs, and like if it's the matter of using this alphabet search, I would rather implement the alphabet search from scratch without involving Monte Carlo research at all, like I did in my BBC Chess engine. So that's just a matter of taste, literally. So I'm sorry for such a long intro to this live stream, but I just wanted to give you an idea of what in particular we're supposed to be doing and why. So we're supposed to be implementing so-called quiescence search to make this enemy policy rollouts to be slightly bit more accurate. And now, without further ado, let's actually try to run the engine from the previous sort of state where we'll have that, and see what we issues have. So I found a couple of issues already. We'll fix those issues, and then we'll try to implement this quiescence search and keep track of this material kind of sort of an imbalance, and that's the way to go. So without further ado, let's go actually. So I just want to make my engine play in versus itself. Okay, and the very first thing that is definitely wrong here is like it's outputting the minus score where it should be not minus 64 but plus 64, and when it plays the move for the opponent, it's the opposite. So this is wrong, even though the game seems to be quite pretty reasonable so far. Still, the scores should be the opposite. So I just dropped this, and I just want to restart my arena. If my computer hangs, please forgive me that. It happens from time to time. So the very first thing we need to do here is when we return the best score here within the search, we need to see minus any policy to return from the proper player's perspective. So save. And well, this doesn't affect the search results or anything. This is just a matter of the score representation in the GUI. So you can do this, you cannot do this, but traditionally, so this leads to the correct results in the GUI. So let's actually try this one more time to see how particular this is supposed to be working. So we start a new game here, and again, just go into the demo self-play mode, and so you see like already the scores are correct. So white has an advantage, slight advantage here, and which reflects. And okay, so already you remember like in the previous game we didn't have this move, this absolutely weird move where bishop actually goes to h3, literally drops the bishop for some reason. Well, but that's the Monte Carlo research. Well, as far as it picks random move or the best moves, well, it might not always be playing the same move. Well, it seems like it insists. Well, yeah, just want to start a new game. Maybe I would be lucky to have a little bit more, a bit more decent variation next time. At least I hope so. Yeah, now we have a little bit more decent variation. So yeah, you see like now it's already kind of better, but again, like it's just a matter of the random factor. So again, like you see, again he just dropped. Oh, hold on a sec. So let's consider this situation. So here it should have just take this knight somewhere. I don't know, probably to e5 would be the best choice, or I don't know, place it wherever, but not leave it, but at least not playing this bishop c4, because this leads to losing the material immediately, and it actually the score doesn't reflect this. So he thinks like he's just better at this position. Okay, so here this is the exact position where we would like to perform quiescence search basically. So this is kind of I just thought that it's a bit tricky on where in particular. So in this position we won't really see the material imbalance, but so we will only see this in the next move apparently. Well, it's another interesting thought, by the way. Well, anyway, I just want to have the UCI command to actually reproduce this sort of a bishop c4. No, this I need the previous one. So here apparently, and copy. Okay, and I don't need arena anymore. Well, I'll close that quite pretty soon. So let me just open the terminal in the current working directory and python 3 engine.py. Just starting the engine in the UCI mode, and here I can say, I can actually paste this, right? And here is the position. So it's probably it's y to move, I believe, and let's say go move time and 1000. Hold on a sec. G5 goes to F6. Is this the same position? Because now it outputs a much better move, to be honest. Okay, now it's different move again, F1 to D3. Well, even this is better, to be honest. Yeah, even this is better. So let's go again, move. Go move time. Yeah, this is a bit confusing, to be honest. So I just can't see, like. Okay, let's try again. All right. Yeah, it's in GUI it makes weird moves for some reason. All right. Okay, and now he does a quite pretty nice move. So yeah. Well, anyway. Well, I just thought, like, how in particular. I just think that when I was doing some tests, I was testing for the material in balanced position in a slightly bit wrong place, to be honest. I'm not sure though, but well, okay. Anyway. Let's actually drop the arena for a while. Well, probably the very first thing I would like to do here is let's create a function called get material score, and it would be taking the board state instance, and apparently that's it. So score equals to 0. So here we'll have the material score, and now let's create the material dictionary, and here I want to make like pawn, and let's make it words of 100 points. Knight, it would be, say, 300s. Bishop would be 350. Okay. Bishop, rook, 500 points. Queen, 900 points. Oh, sorry, should be white queen. And king, this would be 1000. Well, obviously we're not going to be exchanging kings ever, but still. Okay, and here I want to have the black pieces: bishop, rook, queen, and king, and all the values would be negative. We'll now test this function to make sure that material calculation is working properly. So okay, I think that this is it. So here we have the relative material, well, let's say piece values, and here we want to calculate material balance. So return, and we need to take well, hold on a sec. first we need to say for, hold on a sec, I just, oh my god, I forgot how I was doing this. So how was I doing this? We need to loop over the board. Yeah, so for square in range 64, so loop over 64 squares. Yeah, let's say loop over board squares and okay, initialize piece equals to, so we need to say state dot board dot piece at and the square, and say if not empty square, so we can say if piece is not none. In this case, so we need to create, so we already have the score. Score would be plus equals and material indexed by I think we need to stringify. Hold on, guys. I just need to release my cat. Okay, I'm sorry, guys. Just when my cat wants to go outside, she's starting to scratch the door, and that is scratching my heart so hard. So I can't really resist the desire to let her out. Okay, so now we need to take. So this piece is the type of the chess piece or something, so I want to stringify this piece to make sure that it would be like pawn, rook, or whatever. And at the very end we want to return material score, and here we calculate material score. Okay, so now just to make some sort of a tests, here I want to create the chessboard instance, so board, hold on a sec, it takes the state. Well, I will probably, okay, so I just drop this for a while and then I'll bring it back. So board equals, because when we would be testing, we would be using the board instance, and in kind of production would be using the board state, the instance of the state class. Okay, so board equals to, also I think I need to import chess here as well. So chess the board, and I need to pick up some FES, so I just try to grab it from Stockfish Evaluation Guide. Okay, so let's take this one. So this test would be about just to manually taking away the material and see how the score would behave in return. So I want to print this board, the one that we are evaluating material for, and I also want to print the score, and this is gonna be so how did I get material score, I guess. Score and pass in the board as an argument. So now I need to run Python 3 Monte Carlo research.py, excuse excuse me. Okay. Some typo, I believe. Okay, here it is. Score none. Whoa. Oh, I didn't return anything. Okay. So return score. This should be equal to 0, which is correct, because we have equal material. Now let's say if I just try to get rid of one waypoint, it should be minus 100. Okay. And if I just drop some sort of a black pawn, it should be 0 again. Okay, now if I just get rid of, say, the knight, it should be minus 300. Excuse me. Oh, what have I done? Yeah, minus 300, and if I just drop another knight for black pieces, should be 0. Okay, so this it seems to be like the material evaluation is working properly here. Okay, so I'm just wondering now where in particular I should be checking for this material score, because what I was doing when I was preparing for this live stream, I was making this I was checking for the material score within my NNE policy here I was checking that. Might not be the best case ever of doing things. Well, anyway, okay, so anyway, let's say state.board.piece. So now we would be calling this from somewhere from the search. Well, let's start how I did this initially, and then we'll try maybe a bit better way of doing things. So I want to print the state, and I want to print the score, material score, and I want to get material score for a current state, and also I want to pause the execution while taking the user input, just to see the position arising one by one. Okay, so I think that we can run the engine again. Well, unfortunately, I have lost the position. I have lost the position that resulted that bug, but maybe I can just, yeah, I can grab it from here still. So let's restore the position and say go move time 1000. Okay, hold on a sec. Why doesn't F1 to C4? What the heck is that? Yeah. Oh, okay. So he made this bishop move as it was in the game. Okay. Okay. I'm just wondering why my input doesn't work really. Oh, because I probably didn't. Hold on a sec. What was running there? Okay, so I just don't get what was the move. Okay, so this is the move. This is the move. But the material he's showing is probably like white is pawn down. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah, so white is pawn down, but yeah, even though if it goes for some sort of a weird move, yeah, I see where I was wrong actually. Yeah, so yeah, I was doing things totally wrong, to be honest. So it's not the matter of the material not equal to 0. It's the matter of a material difference after making a particular move, actually. So that's the completely different story. Okay, is it not working? Well, anyway, but on the other hand, okay, I'm sorry guys, just been distracted one more time. Okay, you know, like, oh my god, I just thought that just for now, I just want to say that the matter I was using this, the place where I was using this get material score was here in the NUE policy, which is most likely wrong, because as we can see that even though it brings the material difference, it's just the overall game material difference, but it's outside of the context, like of losing material after making a move. Okay, just forget what I just said. So anyway, we probably might have make use of this get material score one day, but for now I just want to get rid of this and quickly implement the quiescence search, and just to see you just to show you the difference in what kind of move it's supposed to be picking up when the quiescence search is available. So let's go for chess program in Wikipedia, and I want the quiescence search, and here is a nice pseudocode of the so-called stand-pat algorithm. So just copy this, and here just make this quiescence search. So quiescence, it would be taken board state, alpha and beta bounds for scores. Okay. Here instead of evaluate, we need to use our NNE probing with the respect to, well, using our NNE basically. Okay, so state, good. This is it. This is it. And okay. Okay. Okay, and the most essential part, we need to loop over illegal moves. So for move in state.board.illegal moves, but the matter of quiescence is the matter of doing only those moves that are captures. So we're not going to be making quiet moves. So we can say we need to pick, let's say, yeah, pick up only captures. So if state.board.isCapture and move as an argument, so only in this case we want to make the move. So to make the move, we need simply to say state.board.push and don't have chess here, right? Yes, I need to import chess as well. So chess.move.from UCI and stringify the move. Maybe not the best ever way of doing things, but at least it works. Okay, and here pass in the updated state minus alpha minus beta. Okay, and here, so this is make move on board. This is the recursive quiescence call, and here we want to take move back and literally restore board position. Okay, so we need simply to say state.board.pop, and it would take the move that was done, the latest move. Okay, so quiescence, and it would be returning the score. So here we have our static evaluation score. Okay, so well, still might have some typos, but anyway, let's try to test this now. So I need my NNE policy. Okay, and I will try instead to return quiescence and send in state as a parameter. Okay, so let's run the engine and just want to grab this position. So if I did everything correctly, now we should be given moves that are not leading to losing this poor knight on f3. So let's try go move time 1000. Quiescence is not defined, so yeah, I made a typo somewhere, definitely. Okay, but where? I think this is the right way. So okay, missing alpha and beta. Okay, well, there are two ways of how we can handle this. We can specify them here, or as within the arguments. Oh, let's make it more explicit way. So this is the alpha value and this is the beta value, like from the standard alpha beta search. Okay. Go move time 1000. D1 to A4. Okay, so this is already a better move because, well, at very least, it gives a check. Well, probably after b2, b4, it would still kind of lose this knight, right? But anyway, this is already a different move. So let's try what are other options it may give us. Still d1 to a4. It's a little bit weird. Okay, anyway, I just remember the behavior of the engine where it runs when it returns quiescence all the time. So let's start by inspecting that behavior first. And well, first of all, I just want to make sure that the quiescence is working properly. So let's go for a self play. Should be going c4, c5, and this sort of a structure. Well, it seems like what I've seen. d5. Yeah, that's the structure. It's a little bit hard to say whether. By the way, one of the downsides when the more complicated position occurs, it's taken really longer than 1 second per move. But good thing here that at very least it kind of doesn't blunder pieces in this sort of a mode. Well, at least doesn't do it that horribly as it was doing before. When I was making this version to play versus AO Light, it wasn't. It was still blundering pieces for some reason, but not that horribly as before. So already this sort of a version. Well, hold on a sec. What did just happen? What did just happen? Well, not again. Some weird moves occurring. You see, like some weird moves. So the rook is hanging. Nobody's capturing that rook. I don't know why. The knight, well, knight is not hanging at the moment. So it couldn't try. Well, it's hard for me to say something. Well, but anyway, it seems to be playing better compared to how it was playing before. But again, like, why to blunder this knight? This is a little bit strange. So just want to have a look at one more time. So it's not protected from blunders yet. So you see, like he could have just put the knight to whatever place. But yeah, he thinks he is much better here. So something horrible is happening with the evaluation. Let's inspect. So at this moment, okay, evaluation seems to be quite pretty nice. Correct. Okay, so why here -2? Maybe because of the positional factors. I don't know. Yeah. Okay. Well, capturing this pawn seems to be just fine. Well, dropping a rook for a bishop. Well, it's a little bit strange, but well, still, this might be okay. But here, why is it? Well, okay. So not capturing the rook, but trying to attack the queen might not be that bad as well. But here, this move, why queen? Why queen to c7? You could have just captured the rook and be much better here. So this is so strange, and still he doesn't capture that rook. So rook goes away eventually. Now for some reason, I don't know why now he thinks he's worse. Oh well, actually he's exchanged down. Okay. Takes. Okay, so white is much better now. Okay, +15. Black is -25. Well, but why to drop a knight here? This is so weird. Why to drop that knight? So maybe you have a better option here, right? Nope. You want to go for a suicide here. Yeah, this is very, very strange. Very strange. Now, okay guys, so let me just grab this sort of a position. I just want to show you another thing that I came up with. Well, at very least, I don't know, I don't have a proper solution for this or something. I just want to share my how my experiments were going here. Maybe you'll... Будь здорова. Maybe you'll find some proper usage for this sort of stuff. Okay, so my wife was sneezing and I just lost my thought, to be honest. Okay guys, so just want to grab this position command, I believe. Okay, let's run the engine. Let's bring the position and go move time. One cell then. So it's gonna play, yeah, it plays h5 to g3, which is absolutely weird. But anyway, I will now show you a little different trick here. So we just get back to our source code, and now we just don't do our quiescence search, but instead we'll go in for a straight ahead evaluation. That should be given a normal move, well, at least not dropping a knight immediately for nothing. Okay, not dropping the knight. Okay, so go move time. Well, by the way, another thing. What? Score reference before assigned. Hold on a sec. What has just gone wrong here? Send score. I didn't get something. Okay. But okay, hold on a second. It still goes for this suicide move. Minus 2513. And what was the score? It was minus 2513 as well. Yeah, this makes me confused even more. I just don't really like this unpredictable environment like Monte Carlo research because of this sort of weird behavior. So just trying to compare the scores. Well, maybe I'm just doing some horrible stuff, some bug here or something. I have no idea, but why the scores are so different. So now it should be making quiescence search, and it gives minus 2513. Okay. Okay, if it just returns 0, I just want to make sure that something that I'm changing in the source code actually affects the behavior of the program. Hold on. So okay, at least it does affect b7 to b7. Even this move is much better compared to just dropping the knight. Okay, and what happens if we just try to return our NNE score directly? $25.13, still the same score. I don't know why this is happening. Well, maybe because I actually don't do this move. Okay, guys, so another thing that is Monte Carlo research specific. Well, let's drop to this quiescence. Let's drop to well, actually, I believe this might be on the cards not only with the quiescence, basically. Okay, so another absolutely confusing thing regarding Monte Carlo research algorithm that I've discovered is the following. So if we say go move time 1000, so 1 second, so he gives this weird move h1 to g3, but let's give him just more time to think, and in most cases it should be given, oh my god, you're still giving this h5 to g3. Well, but hold on, at very least this is with the static evaluation. Yeah, I've been changing the I've been checking this with this dynamic one. So let's try again. Just want to prove that it would be making a different move. Oh my god, it's not gonna be making a different move. Why are you sticking to this knight sacrifice here? It's not giving anything at all. Just makes the position much worse. Okay, I have no idea why this is happening, I swear. Yeah, very weird situation here. I don't even know what could I do. What I tried in my test was a bit more promising compared to this disaster, to be honest. I don't even know what to do here. Quiescence. Well, at very least we can try to have a look at how the quiescence behaves. And we can say print state, and we also can print score. Yeah, at very least we just try to have a look what's going on within the quiescence search. So paste. You kidding me? Why you don't? Oh, that's because I forgot to say input here. Okay, let's make it one more time. So okay. Hold on a sec. Who is to move? Okay, so pawn takes, or what was that? Hold on a sec. Hold on a sec. I just want to... Okay, guys, just hold on a sec. Maybe I should change the board side here. Oh, this might be interesting. Hold on a sec. Okay, so it's kind of white to move. Oh, so hey, hold on a sec. I see that it's kind of white to move. No, this is probably correct. Yeah, and then he just drops for some reason. I don't know why. He drops here. I don't know why it drops. I don't know, guys. Just, you know, like when I see this sort of the behavior that I can't understand, I'm just losing the motivation instantly. I kind of have no idea what else to be done here. That's the reason why I didn't really want to keep going with this live stream, because nothing but suffering and proving that Kumak again is a dumb noob that has no idea about how to code, how to deal with Monte Carlo tree search completely, which is true, obviously. Okay. Can I do at least something? Okay. Yeah, I just had an idea of changing the site, so maybe no, I just can't change the site without taking care of in peasant square and lots of parameters. Well, one should run the quiescence search actually after the move is made. And it seems like I'm running the quiescence search actually before the move is made. So how do I know? How do I adjust the score? Hold on a second. Just this lack of understanding of how this Monte Carlo research works actually makes me just going for a trial and error method instead of doing something consciously. Okay, so execute round. So he's getting a reward. So he's selecting the node. So this might be either existing node or it goes expanding the node and goes deeper. But anyway, this reward comes for a leaf node, right? So this comes for a leaf node, and the reward is holds reward holds the score returned by this NNE policy, right? Yeah, because rollout is equal to NNE policy, yeah. So whatever value we have here for our leaf node, well, so it seems to be like, so I'm just trying to figure out whether the move was made on board or it wasn't. What if I just try to print node.state and pause the execution? Excuse me. Yeah, now it makes a normal move. I don't understand anything at all. Execute round. I should have seen this state at the very least, I don't know, many times. Why do I see it only once? Like here. Okay, maybe, hold on. I just still can't understand where exactly do I perform this quiescence search. Okay. So, okay, seems like I have to select on the node. Okay, so did select the node, and this is the node, so this is the node we're returning the quiescence score 4. Seems to be correct. But for some reason when I use this input, it just, oh, that's because of the time. Okay, I finally realized that's because I ran out of time. Okay. So can I somehow use this sort of a stuff? Yeah, so just going for a fixed number of iterations. Man, you kidding me? Oh, what have I done? Yeah, so correct. So not the time limit, but iteration limit. Okay, so every time. Okay, so this is getting more interesting. This is getting more interesting. So now I can, so let's print this stuff after getting the reward, and I also want to print the reward as well. Free. Well, the sign of the reward is a bit strange to me. Okay, and if I what else? And I'm just confused with the sign of the reward. Is this the matter of the question search or what's wrong there? Okay. Because knight g1 to h3 can be better than knight g1 to f3. No, it's not the matter. So the scores are correct. It's correct. At least they are the same. Yeah, because here actually quiescence behaves like, yeah, if there is no so only, yeah, okay. Okay, it's completely unclear to me, but I'm just wondering where can I track this material difference? Every next round might be completely different board position, so it's not an option, I guess. Yeah, guys, the more I do stuff like this, the more I realize that you just drop doing something that you're noob and dumb at completely, and just go and do something that you can do properly. And again, like, if not only that commentary on YouTube, I would never be going for this sort of a shame here. Okay, so I just, no, maybe I just go for the implementation that I came up with in my tests, no matter they are wrong, having some mistakes or something. So this is what I was doing actually. But if the material score is not equal to 0, which means to, but hold on a sec. Well, if the material score is not equal to 0, this might not only mean that the capture has occurred in chessboard. It also might mean that there could be a situation where we just have an unbalanced material, and in that case we would be calling this quiescence every time. But at the same time, so I was also calling this sort of a normal evaluation. So maybe, well, okay guys, I'm just like the more the stream goes, the more I'm kind of losing my motivation. So I just want to finish this. I will show you what I came up with so far and just go for a final game and probably drop this because it really starts making me nervous. I just want to hit the screen with my fist or something. I don't know. It's just making me nervous and pissed off completely. Okay, so let's drop back to our initial settings here and don't do this stuff. Okay, and So here I just want to make it score. And here I want to get material score. So let's call it material. Oh, let's say if material in balance. So we can say if get material score. So if material score is not equal to 0, which means that there is an even number of pieces on a chessboard, white and black pieces. In this case, I want to return, I want to calculate the quiescence score. So let's call it quiescence score. And I just call this quiescence and the state like this. And I want to return which one is better. So either the score or the quiescence. So here we want to get the quiescence score, and here use either a direct static evaluation or quiescence score, either direct static evaluation score or quiescence score. Depending on which one is greater. I think this might be fine. This might be just fine, and otherwise, let's say on material imbalance, and here on material balance. So literally else, and I just want to return the score. Just return use. And that's it. Well, at very least this does change the behavior. Well, probably still lots of bugs, but at least this does change the behavior. So let's make sure that material score state at very least it would now be trying to combine the playing style from the previous version when we didn't have the material score, which I personally consider to be better positionally. And also when it comes to some unbalanced position, but I thought that this would be only the matter of currently unbalanced position when, say, a capture occurs on the board, but it would also be the matter of generally unbalanced position, which I'm not sure if that is a good idea to have, or maybe we shouldn't take pawns into account here. Well, anyway, I just want to show you the new behavior. So it should be started playing like without quiescence, but at the same time not blundering pieces like it was doing before. Well, this move is a little bit strange. So you see, like, oh my god, what have you done? Oh man, what have you done? Why did you just give up the knight here? This is so weird. Gives the pawn. Oh, this makes me so depressed. If you could only know how depressed this stuff makes me. And it still goes for the same sort of a position. No, it's not the same already. So yeah, if you're lucky, then it might be a bit different. Yeah, no, it's not that bad. Well, it's hard to say, but so what about the material seems to be equal. Well, at least this is more like, I don't know, something that looks like a reasonable chess play, but you remember, like, from the previous iteration, is just drop the knight in the opening with no reason at all. Okay. So why don't you play this move e4 to e5? You should play e4 to e5. Oh my god, finally. Finally. Why don't you take the knight? Oh man. So you see, it's completely unclear, like, how it behaves, basically. The only thing that I can say that, well, at least in theory, I already afraid to claim something, but in my previous tests, what I had, so if it just increased the level to say 3 seconds per move, it should be, in theory, it should be playing more decent moves and try not giving pieces away that horribly, at very least. So, just wondering, is my mic actually being turned on? Yeah, thank God. Okay. Gonna capture in c4. Nobody plays Queen's Gambit like this. It's gonna be in peasant capture. It just drops the pawn. You're gonna change the queens at very least. Nope. 1, 2, 3, 4, 6. So just drop the pawn. Well, at least it didn't drop the piece. That's why it's considered to be worse. Yeah, hopefully at least he considers to be a bit worse, which is already a good sign. Okay, I would have played knight to e5. Well, at least try to castle. So, you know, guys, what can I conclude from this last part? So, I think now it's clear, like, why I don't really want to continue this series, because again, like, nobody's is doing Monte Carlo research in this weird way. So one needs either a policy hat being returned from the neural network to affect the move selection logic, or if you don't have that, in that case, so-called alpha beta rollouts should be implemented. That, and I have no idea how in particular that is done, basically. Well, so far we have quite pretty not that bad position, I believe. At least it didn't, well, there was a tactics like takes, and if takes, then loses a piece. So it's not really that bad so far. I'm not making this plain versus AOI chess engine because it would be losing horribly. I just don't really want to get depressed again by seeing that. But did you just drop? Oh, hold on a sec. Nope. Oh my god, what have you done? You see, like it was going so good until you just dropped the queen for nothing. You know, like just drop the queen for nothing and that's it. I have no idea why this is happening, to be honest. This is a complete mystery to me. So this is so weird. Like why this could have happened. Well, at least try to win the queen here. Nope. Try to queen. Are you gonna get mated? No, it's not gonna get mated yet. Well, actually, the position is not really that bad. Well, it is horrible. It definitely shouldn't give up the queen. It really shouldn't give up the queen. But from the material perspective, this might be not even that bad. Okay, I'm gonna get mated now. Yeah, now he is gonna get mated. Why didn't he mate? He could have made. Didn't he see it? Probably. I guess he just didn't see it. Okay. And one clever move for the entire game. Try to make an escape square for a king to avoid getting mated. Well, at least he actually tries to defend the pieces sometimes. So, what my summary for this sort of a project would be, so like once probably it was yesterday, I'm not sure, or maybe a couple of days ago, I just saw a video on YouTube entitled like 30 weird chess algorithms, and there the guy was trying to make some really like almost random algorithm, so to play chess against. So he wasn't doing any searches, basically, like minimax or even Monte Carlo research. He was just doing some sort of protecting the pawn on f2. What a fantastic move! Oh man, you must be kidding. Okay. Well, at very least, this game actually seems to be, yeah, quite pretty. Not that bad at this point. At least it's not giving its pieces away. So maybe just go a5, try to queen and win here. Nope. It's gonna be a draw. Nope. So just go to a4 to a5. Oh, finally. You're reading my minds. Okay. Just try to promote the pawn. Oh my god. Unbelievable. He finally realized that that's the good idea to promote the pawn. And now, oh my god, now white is better. Not that fast, so he's going to... What are you doing, man? Why are you dropping another pawn? Okay, if it just takes, and then queens. Okay, can he queen now? After this weird move? Can he queen? I don't understand what's going on the chessboard. So what I wanted to tell you guys, that if you really want to have a chess program that you want to be playing against, and that would mimic the human's behavior, like let's say it's making strong moves and then just accidentally drops the queen for some reason, well, this is something you really want to have in this case. Yeah, but if it's the matter of playing decent chess versus other chess engines, definitely it's not an option, at least in this sort of an implementation. So, yeah, I can't see any other, I don't know, any other application for this app other than for kids who, I don't know, like 3-year-old, oh my god, 3-year-old kid who's just learning to move the pieces across the board and probably doesn't understand the rules properly yet. So maybe that's the good level. Oh my god, you see, like he just drops the queen, like, and king even doesn't recapture it. Oh man, Oh, this is so weird. I'm just tempted to know if he actually got made here, because like for some reason, okay, he just drops the queen again. Like, I don't need a queen. That's a little bit too much. I don't know, like, why is this happening? But it seems like the deeper it goes into the game, the more random its play becomes, basically. So it's really hard to say, like, why is this happening? It would have been nice to connect the rook one day, like rook a1, say. Was it a mate on rook a1? Well, probably not, but man, what are you doing? Yeah, maybe just allow him to queen, right? And maybe black wins this game. Why not? Yeah, why not just... Yeah, it seems like more random every next move. Just play rook b1 and then just queen, I don't know, somewhere. It's the mate in 2 position. Why don't... Yeah, this is so weird. This is so weird. Yeah, you just resign for white here. You just resign. He's not taking a pawn. What a weird thing. Yeah, it's a well-known problem of an NE when, of the Stockfish in NE, when you're kind of much better. It often happens that it's actually not capable of mating. One solution might have been to bear in mind the 50 rule move during the evaluation. I'm just wondering, did I actually implement that in my preparation version? I don't know if I did. No, I didn't. I was trying that, but probably later on I just dropped that. Oh my god, did it just... Where the knight has gone? Oh my god, what has happened? Did he exchange the knight for a pawn? What a weird thing. Just drops the queen. And the most interesting thing, the king is not accepting that. Okay, guys, sorry, I just can't watch this shit anymore, because yeah, it makes me so depressed. So, well, at very least, I hope that... Okay, just drop away from here. I think that at very least, at the moment, it kind of more like clear, like on why actually I don't want to deal with this stuff anymore. So my kind of initial attempt was just to see how the pure Monte Carlo research algorithm would behave, and people from Talk Chess, like smart guys, not the dumb noob like me, but the smart guys from Talk Chess forum actually told me that without an external audience, the Monte Carlo research would most likely be coming up with some sort of random moves from time to time, like dropping queens, sacrificing material for nothing, with no logical explanation for that. And that is the exact reason why either the policy had from the neural network or the alphabet rollouts should be implemented along with the Monte Carlo research algorithm to make it playing decent chess, basically. So as far as I'm not doing, I'm doing neither of those. It's quite pretty predictable that the behavior goes like this. There is nothing really much to get pissed off from. So I think this is kind of quite pretty clear. Okay, guys. So this is it from my side. I swear I didn't really want to make this very last part, because it shows like my total dumbness without any hidings, basically. I don't know how to say that. So like total noobness, total dumbness, and I have no, like... Okay, just forget that. So think this is it. And to be honest, to be very honest, after this experiment, even though it was predictable and I kind of knew how it's gonna end up eventually, but I don't know, it for some reason makes me so depressed that I'm kind of losing I'm losing the sense for keep going, basically. I know that sounds horrible, but to be honest, I have no idea like how in particular am I supposed to proceed with this channel and the further videos. I have some ideas, but you know, like what I've realized that I was trying to implement some very, I don't know how to call it, very basic neural net on my own. I failed horribly. That was absolute horror of how that was going. You know, like I was never feeling so noob when I was trying those to implement some sort of my own neural network. I was trying a very very simple stuff, just like a single layer perceptron to at very least try to predict the material scores, and I failed. I couldn't handle that. I don't know. I just when I just started thinking about when I started trying doing something, I was trying for about 3 weeks, and the more attempts I was doing, the more depressed I became, basically. So I don't know, like I'm just feeling angry, and I just feel like I want to crush something near me. I don't know, like I want to hit somebody. Just the anger from within is coming. Like I don't know. This is absolutely weird. Definitely not the emotions you should have obtained from coding. So I think that most likely the life is telling me, like, come on, dude, that like neural networks are not for the code marking king like you, but for someone a smarter guy than you, probably. And literally the same thing I can conclude regarding the Monte Carlo research algorithm as well, because it's not that straightforward as the alpha beta is. And you know, like I might be wrong though, but it seems like it just needs some sort of a different both goals and mind and understanding, and probably a bit different consciousness. I don't know. I just feel like with my code making approach, what I do really sucks, and I can do nothing to this really. So this is kind of it. I've probably said too many offensive words already to get this video monetized one day, but I think this grab is not worth of that, even if this channel would ever reach 100 subs. So this is it from my side, guys. I have no idea what am I supposed to be doing next, to be honest, and the same issues I'm facing on my different channel, my Codebank Against channel as well, related to web scraping. I'm sick and tired of web scraping, and I don't really want to make it anymore. I really feel depressed, and I have no idea how to proceed. So if you have any ideas, like feel free to leave the commentaries below this video, and probably that would make some, I don't know, maybe that would make something to me. Okay, so this is it from my side. I hope that would be the next time. So until the next time, and take care.